In order to complete the square, you will need to have watched the video on making a perfect square to basically have that background. So in this video, we're going to complete the square. So I want you to consider the expression y equals x squared plus 2x plus 3. And we're going to use the idea of perfect squares to be able to put this in completed square form. So we do know from the previous video that in order to make this any expression in the form y equals x squared plus bx, we can add half the coefficient of b squared to make this into a perfect square. But obviously with this, we've got an extra 3 hanging on here. So I'm going to show you how we're going to work through this. Basically, I'm going to treat it as I'm solving an equation. So let me write the expression down. Y equals x squared plus 2x plus 3. And I'm going to do the same to the left-hand side as I do to the right-hand side. So to begin with, I'm going to subtract the 3, because by subtracting the 3, I then get it into this form. So I get y minus 3 equals x squared plus 2x. Now that allows me to just concentrate on the right-hand side and make the right-hand side a perfect square. So in order to make that a perfect square, I need to add, so over on the right, I'm going to write that. So I'm adding 2 over 2 squared, which of course is 1 squared. So I'm going to add 1 squared to both sides. So I get y minus 3, add that 1 squared, equals x squared plus 2x plus the 1 squared. Okay, so over on that right hand side, this now makes a perfect square because I've got x squared plus 2x plus 1, which then factorizes perfectly to give me x plus 1 all squared. Now obviously I need to check the right hand side, so I've got y minus 2 once that's simplified, and I still have y minus 2 on the left there. So finalizing this to make it in what we call completed square form, I'm going to add 2 to both sides so that it's y equals x plus 1 squared plus the 2. This is often used, completing square form, to either solve equations, this is a useful method, or it might be used for turning point form, which we'll look at later on when we start looking at graphs of quadratics. And sometimes we use it to fully factorize, which will be another video, so you can watch another video on that. So let's do a second example. We're going to try a few more. So remember, this is called completing the square. So when you get an expression like x squared minus 4x minus 5, I always put it equal to y, so I can then treat it as an equation and I can complete the square just as I use the method above. So I'll just place a line down the right hand side to show you all the working. So the first step is to add the 5 to both sides, because then that enables me to make a perfect square on the right hand side. So I'm left with x squared minus 4x. Now remember, to make that a perfect square on the right hand side, I need to add the coefficient, half the coefficient of b squared. So I'm going to add minus 4 over 2 squared, which of course is minus 2 squared, which is 4. Now if I add that to both sides, I get y plus 5 plus 4 equals x squared minus 4x plus 4. So simplifying the left, I get y plus 9, and simplifying the right, I can now write that as a perfect square and fully factorize by writing x minus 2 all squared. Finishing off in completed square form, I'm going to have x minus 2 all squared minus the 9. One more. Let's do y equals x squared minus 8x minus the 3. Again, show you I'm working on the right hand side. So I'm going to add 3 to both sides. So that gives me y plus 3. And the right hand side then can be made into a perfect square by adding half the coefficient of that minus 8 and squaring it. So that will be minus 8 over 2 all squared. I'll be adding 16. Okay, so that's minus 4 and then squared gives me 16. So I'll be adding 16 to both sides. So simplifying that, hang on, I'm not simplifying yet, I'm just writing down what I've just said. So add 16 to both sides. Right, simplifying now, on the left hand side I get y plus 19, and on the right hand side I get perfect square, which can be factorized to make x minus 4 all squared. And then finally, making y the subject, I get y equals x minus 4 all squared minus 19.